Okay, the problem that we have is a rancher has 300 feet of fencing and wishes to enclose 2 adjacent rectangular corrals. Using calculus, find the dimensions that yield the maximum area. So try to draw a picture, and we know that all these lengths are going to be the same, so we're going to call those y. And we know that these 2 lengths are going to be the same, so we call those x. First thing you want to do is make an equation. So we can see that we have 3 y's and 2 x's. So 2x plus 3 y's, and we were told that we have 300 feet of fencing, so that equals 300. Now we need a formula. We're trying to find maximum area, so we go area equals x times y. The next step is to substitute. So you take the equation that you're given, 2x plus 3y equals 300, and then solve down to get x. So we get x equals 150 minus 3 halves y. Now we're going to plug the information that we found for x into our equation for area. When we do that, we get a equals 150 minus 3 halves y, and we multiply that by the y that comes from here. The next step is the calculus portion, where we have to find the derivative of a and then set that equal to 0. So our derivative of a is going to be 150 minus 3y equals 0. Then we solve to get our y, which is 50. And then to find our x, we just take our equation that we had up here, where x equals 150 minus 3 halves y, and then we plug 50 in for y, and we solve it to get x is 75. So we know that our dimensions for the corral to get the maximum area is going to be 50 feet by 75 feet. But we want to make sure that we did find a maximum, so we take the second derivative of a. So the first derivative of a was 150 minus 3y. The second derivative is going to be negative 3. This tells us that we're concave down, and if we draw a picture of a parabola that's concave down, we can see that we're going to have a max.